Hi, it's Christopher from Math Aesthetics, maker of MathPaint. In this tutorial, I'm going to show you how to use repeaters to turn a simple plot or geometry drawing into a complex composition or pattern. Often in generative graphics and mathematical art, a shape or design is drawn repeatedly with some small change each time to create a mesmerizing effect. MathPaint lets you create these kinds of effects using repeaters. A repeater is a command that tells a layer to draw itself more than once, applying an operation each time which changes the drawing. Let's look at a simple example with a geometry layer that has a single shape. We'll use this nice 10-pointed star. In the model settings, we scroll down and click the Add Repeater button to add a repeater to this layer. This brings up a dialog that has the repeater settings and a preview of what it will look like. The operation pop-up controls what kind of change the repeater makes. It is set to move x, which means shift the layer coordinate system this amount in the x direction, then redraw the layer. There is also a repeat count field set to the default value of 10. This controls how many times the layer is drawn. Let's change it to 5 and click Create Repeater. You can see now that the layer is drawing its content 5 times, shifting horizontally a little bit each time. We also now have a repeater control group in our model settings representing the repeater we just added. We can make some changes here. For example, let's change the amount the layer is shifted for each repeat, say from 0.5 to 0.6, and notice how this changes the output. We can also change the number of repeats here. Let's change it from 5 to 8. So that's the basic behavior of a repeater. You can use repeaters with any of the first 4 layer types: Cartesian plots, geometry, polar plots, and parametric plots. These are the layer types that tend to just draw lines or curves rather than filling in every pixel. Repeaters support a variety of operations. Each repeater you add supports a single operation, but you can add more than one repeater to the same layer. Let's go back to our example. We already have a repeater that is shifting the model axes horizontally and redrawing 8 times. Let's add another shape to this layer, let's say a rhombus. Because this repeater is applied to the whole layer, our rhombus is drawn 8 times with the same x-axis shift as the original star. Now I'm going to select these shapes by clicking on them and drag them into new positions by their center handles. Notice that the shape selection in a geometry layer just shows the original outline of each shape. We don't actually have multiple copies of our star or rhombus. The layer is just drawing the same objects multiple times with the repeaters. Let's add another repeater to this layer. As I click the operation pop-up, take a moment to see all of the types of operations a geometry layer supports. There are operations to move or zoom the coordinate plane, operations to move, scale, or rotate a shape, and also to shift individual vertexes in a shape. There are line width and color operations, and finally some transform operations, rotate, scale, and translate, which are applied to the total layer image. I'm going to choose Rotate Shape. When I do this, an additional shape pop-up appears, and it's set to any, meaning this operation will apply to any shape in the layer. In the preview, we can see that it's affecting both the star and the rhombus and how they're drawn. Now I'm setting this repeater to apply to one shape. I'll choose the star, so the rhombus is still redrawn from the MoveX repeater, but is not affected by this rotate operation. Next, I'm going to change the delta. This is the amount that's applied with each repeat. For our earlier MoveX operation, the delta was in terms of the coordinate plane x-axis of the layer. For a rotate operation, this delta is an angle that's added with each repeat, expressed in radians, so a value of 3.14 is approximately 180 degrees. I want a very slight rotation of the star with each repeat, so I'm going to set the delta constant to 0.05. And there's our result. Back in the model controls, we now see both applied repeaters. We can click the Enabled button on our repeaters to toggle each one on and off and see how drawing looks without the rotation or without the X move. Now let's add a Cartesian layer and see what kinds of repeaters it supports. We've got a function here in X with coefficients a, b, and c. We add a repeater and check out the operation options. Repeaters apply to layers, so our preview only shows our Cartesian layer content. The geometry layer and its repeaters are completely separate. In the repeater operations, we see the same coordinate system move and zoom options we saw in the geometry layer, as well as the line width and color options and the layer transform options. We don't see any of the shape options, but there is something new that relates to our different model. It's the coefficient value. Setting this makes quite a difference in how our plot looks. What we're seeing in the preview is our function drawn 10 times, and every time a value of 0.5 is added to each coefficient. That is, we're adding 0.5 to the values of a, b, and c that are used by our function. If we make the delta value smaller, say 0.1, we can see the plot starts to resemble the original function a little more closely. Let's leave it at 0.2, but instead of adding to all coefficients, we can use the coefficient pop-up to only apply the delta to one of them at a time for this repeater. Now let's try setting a negative delta, which decreases the coefficient value for each repeat. And we get these results. I'm going to create this repeater with negative 0.2 as the delta for the coefficient named b. So our Cartesian function is now being drawn 10 times and subtracting 0.2 from the value of b on each repeat. I'm going to add another repeater to this function, and now let's play with the color that's used to draw it. I'm going to choose color, hue, angle as the operation. Now, these color values, hue, brightness, saturation, and alpha, are all unit values, meaning they're between 0 and 1. In the case of color hue, the value cycles around the color wheel. So for a gradual change between nearby colors on the color wheel, you'll use a small delta, taking into account the number of repeats. I'll use 0.033, which, applied 10 times, takes us about 1/3 of the way around the color wheel. And that's the result of combining a color, hue, and coefficient repeater on a Cartesian layer, as well as an X move and a shape rotate repeater on a geometry layer. Now, so far in all our examples, the repeater has used a constant value for its operation each time. Repeaters can also obtain the delta amount they're going to add from a function that you define. This is pretty cool because it lets you do more dynamic things than just the uniform change of a parameter. Let's try an example. Here's a document with a geometry layer containing a single shape. I'm going to add a move X repeater with a pretty large number of repeats. Let's redraw 75 times. I'll reposition this where I want it in the canvas, and now let's add another repeater. This will be a move Y repeater to shift things vertically. Instead of the constant delta, which just moves the same amount every time, I'm going to select expression delta. Right away we see in our preview that we are no longer moving in the Y direction in a constant way. The image starts redrawing with very little movement in the Y direction, but then increases and the image goes off the screen. The expression edit field here reads repeat divided by 10, and it says the integer variable repeat may be used. In this expression, repeat is evaluated as a number. The first time the layer draws, repeat has a value of 1. The second time it draws, repeat has a value of 2, and so on all the way up to 75. We can type any mathematical expression in the MathPaint expression syntax into this edit field and use repeat as the variable to control what delta is applied for our operation. As an example, let's add a call to the cosine function, which is a periodic function that will increase and decrease between 1 and -1. Let's just try cosine repeat over 10. That's pretty cool. Our first repeater is moving our coordinate system by a constant amount along the x-axis for each repeat. But this new repeater is using an expression and the value of the repeat variable to move up and then down and then back up in the y direction. Expression repeaters are supported for every operation, just like constant deltas. So you can use expressions not just for movement, but also for rotation, for color, for function coefficients. It's a really powerful generative art tool that I hope you'll explore. We have a forthcoming tutorial on the MathPaint expression syntax, but you can get an overview by selecting Expression Syntax from the MathPaint Help menu. Also, look for an upcoming tutorial on transforms, which, unlike repeaters, work on every layer type for rotation, scaling, and translation. That's it for this tutorial. Hope it was helpful. Enjoy using MathPaint. We can't wait to see what you create.